All right, here we are asked to see if these two expressions are equivalent. So a couple things that I'm going to do here. It asked me to do two different methods, and I'll do kind of two different methods, but it gets a little bit chaotic. So the first thing I want to make sure everyone understands is that when I have something to the power of 1/2, that's the same thing as the square root. So this right side here is really the same thing as x plus 3 times the square root of x plus 2. And I'm going to try and make the left side kind of equal to that. Again, I'm going to try two different methods. They're a little bit, I would say, confusing at parts, but I will do my best to try and simplify how I'm speaking about it. But okay, first things first, on this one here, I'm going to change these fractional exponents into radicals. So like I just said before, this here is just the square root of x plus 2. This one here, because it is the exponent of 3 over 2, it's still a square root because the denominator is 2. So it's x plus 2 here. But all of that to the power of 3, because that's what the numerator of that exponent is. So from there, to simplify this, remember I'm multiplying that by itself 3 times. In this case here, oops, I don't need that. Yeah, I'll go ahead and write it out actually. Square root of x plus 2, there's 3 of them, square root of x plus 2. And when I multiply two square roots of the same thing together, right, when I multiply these two things together, the square root goes away. Just like if I take the square root of 5 times the square root of 5, that's the square root of 25, which is just 5, right? This radical just went away when I multiplied them together. So now to rewrite this, I have my original square root of x plus 2 plus x plus 2, because these two things here multiplied to get x plus 2, times the square root of x plus 2. Now here is another reason that I feel like this one is tricky. So I now have these two things that I'm adding together. And just like when I have like x plus 2x, right? I have a common variable here, and then when I add them, I add these coefficients to get 3x, right? Because this is technically 1 plus 2 is 3. That's the idea that I'm going to use to try and add these two things together. So on the left side, again, my like x's in that last situation, this is my like variable. These are the things that are the same. And then the coefficient is going to be 1 for this one and x plus 2 for this one. So again, what I mean by that is I'm kind of going to be adding 1 plus x plus 2. So x plus 3 is what that is equal to, times the square root of x plus 2 when I add those things together. And that is the same as what we started with. Now again, I know that last step is a little bit wonky, so we'll try another method and hopefully that sinks in a little bit better if this one didn't make sense. So second method I'm going to try, I'm actually going to use u substitution to try and help show this on the second one. U substitution for this one, I'm just going to say, I'll go ahead and do the same first step here and change them into square root of x plus 2, and then the plus the square root of x plus 2 to the power of 3. And now I'm going to say that u, I'll put it simply, is equal to the square root of x plus 2. Now, why does that help? Well, if we plug that in, we got u plus u to the power of 3. Well, now I can factor out a u, right? Greatest common factor is u. I got 1 plus u squared. Now I'm going to re-substitute back in x plus 2. So I have x plus 2 times, square root of x plus 2, that's my fault. Square root of x plus 2 times 1 plus the square root of x plus 2 squared. And now the square root of x plus 2 squared, this one right here, well, the radical and this cancel each other out. I'm left with just 1 plus x plus 2 times the square root of x plus 2. And when I simplify this, I get the square root of x plus 2 times x plus 3, which is the same thing here. There are a couple other ways to do this as well. There's lots of different possibilities, but those are kind of the two that come to mind when I look at it to start. But there's lots of ways to show that these two things are equivalent.